Good morning, good afternoon, good evening, depending on the time that you see this video. Today we are going to talk about constructors and destructors. What are constructors and destructors? Constructors initializes an object, while destructors cleans up when the object is destroyed. So let's write a constructor. So we come here, class, class is our class name. Public, make it public. My class. So constructor initializes an object. This is it. So this is how. That's the rule for writing a constructor. So what about destructors? Destructors cleans up when object is destroyed. Let me comment this page. So want to write a destructor. This is the syntax. Main class, and you terminate. Yeah, so this is the rule for writing a destroyer. So we're going to talk about class. What are classes? What are classes? A class is a user-defined data type that acts as a blueprint for creating objects. So it groups data, as the variables and functions, the method, into a single unit, following the object-oriented programming model. So this is actually a structure of a class. We say that this is a constructor and destructor, and this is the destructor. So we want to create a class. So a class student, class variable cost. So class student. Public string name. H. Don't forget the declaration of a class be done on top of the int main or under the int main. Here we are doing it on top of the int main. So students S1 generated S1 in each is the name. So the S1 makes it able to inherit its attributes. So return 0. So let's try executing the code. So we can see it executed the name and the age. So this is how we use classes in C++. And the key parts of a class is the data, members, member function, and assets specifiers. The data members are the variables that holds the objects, like the name and the age. And the member functions are the function that operates on the data, like the display, info, and asset specifier. Define who can access the members, whether it's public, private, or protected. Why use classes? For encapsulation, reusability, abstraction, and modularity. Encapsulation simply means group data and functions together. Reusability, you can create multiple objects from one class. Abstraction, it hides all the complex implementation details. Then modularity, easy to manage and maintain code. So we move on to namespaces. What is a namespace? A namespace is used to group related variables, functions, and classes to avoid naming conflict. So the variables, functions, and classes that are related, when we group them, it's called a namespace. We have two types of namespace. We have the standard and the user. So the standard one is the one that has been installed in the C++ library, like the hashtag, the hashtag include IStream and the CMAT and the rest. So whilst the user-defined header files are created by programmers, they are imported using what? User-defined. They are imported using hashtag include, then your file name. Your file name is J something. What are the file name? Okay, maybe JUY. So they are imported using this rule. 3 types of names. We have the inbuilt preset, which are the standard object like cout and cin, the inline namespace, they are accessible without the namespace name, the anonymous namespace, and the ones with no name. Members are restricted to the current line. Okay, so let's try writing a cool namespace. You will need this. Let me just comment now. These are the 7 icons. So namespace are also declared and called. So yeah, let's declare our namespace. So namespace GCT. Now code above. Avoid which so avoid name. So data type, which is a data type which is not returning nothing. So that's why we are using a void. Welcome. So it's like we're actually greeting. Get here. And return data type. So it returns value in 2025. Then we come and assess the members. So this is a symbol for assessing members in namespaces. Switch. Carrot. Don't forget, that's is case sensitive. See. Welcome. It has secure the code. Welcome and current academic year. So the namespace, the institute defines a custom namespace named GCT, and inside the namespace we have two members, the function greet and another function gets here. So this is a function, and the int function, we access those members using a scope resolution operator. This is the scope resolution operator. Here, GCT use scope greet calls the greet function. This from the GCT namespace. This is how actually it's executing namespace in C++. So we move on to exception handling. What is exception handling? It allows you to manage errors separately from main logic using the try block, catch block, and throw keywords. So the try block actually contains risky code. The catch block handles the exception. Then the throw keyword sends the exception. So let's write a program using the try, throw, and catch to handle a division by 0. So let me just turn all of this, we won't be needing them. Okay, so int a equals 34, b equals 9. soil, if B equals 0, then this is true. That's the exception that true division by 0. So output as A divided by B. After trying, you should catch the block. That means one is the exception. So catch and constant. Current. Outputs. Output. So let's have a good approach. Good. So easy. You see the execution of the code. I'm trying to tell him that try if B is equal to 0, throw division by 0, output A divided by B. Since B is not equal to 0 but rather 89, it didn't want. It won't throw division by 0 unless B was equal to 0. Okay. What are the benefits of exception handling? They separate the normal code from error handling code. Then it handles only selected exceptions. It also allows grouping and handle similar errors together. Thank you guys for joining my class. Hope to see you in my next lecture. Bye.